floor is yours.
All right, Raymond.
All right, today we're going to be talking about cross-site scripting. We're going to give an overview of what it is. It's also referred to as XSS. We're going to talk about the different types, when it was first used or discovered. We're going to have some recent examples of the cross-site scripting. We're going to mention what we should do when the site is compromised. That's going to be covered somewhat more under the consequences and legal issues. We're going to go over how to prevent cross-site scripting overall. And then we're going to have some live examples of cross-site scripting attacks and proper ways to patch cross-site scripting.
Okay. What is cross-site scripting? So they're basically injection attacks that are based on HTML to rewrite or change the input code of the website. Malicious code can be inserted in many forms, including but not limited to JavaScript, VBScript, ActiveX, Flash, CSS, and many more. Basically, any language that is capable of interacting with the website. JavaScript is easily the most common because it's what most websites are based off of, and it's the easiest to do it with. The attacks can come from any kind of website, even ones that are normally trusted. The main flaw with the web application is that a lot of them require user input, and they don't validate the input before accepting or executing whatever it is the user inputted. So this allows for malicious code to be inputted into the site and executed without checking or preventing it. Also, the sites or user browsers usually do not have a way of recognizing that it is malicious code without, like by default, you can implement stuff, but by default, there's no way of recognizing that it's different than just them typing in their username. The browser also assumes that whatever website you are on is a trusted website, which is how, so the website already has access to your cookies, your session, and all that. And once an XSS attack is launched, it can gather that information that your browser had already said, okay, this website is all right, I'm going to give it this information. And then the XSS can grab it from the website that your computer already trusted. It can also be used to cause or to rewrite contents of the page. For example, if a site requires a login of some kind, it can hide the normal login and put a false one there that when the user inputs their username or password or whatever, it will either save it or send it to the attacker. Sometimes after that, it'll either just stop connection to the site, redirect them back to the main site, or say like there was an issue with your username and password, so the user might not always know that their information was taken. Sometimes the code can cause pop-ups. It can have an interactive thing that the user has to click on to get out of the way or move or interact with in some way, which can cause other events to occur like downloads or redirects. Sometimes the code will cause the website to entirely bypass the normal site and redirect the user to a site entirely controlled by the attacker. If the code is written well enough, it can even cause files to be installed by the user clicking on the pop-up, or sometimes even without interaction at all. Just accessing the site can cause a redirect to a download link. These files can be really anything, including Trojan horses, ransomware, any other kind of malicious software.
Cool. So when cross-site scripting was first discovered, they categorized it in three different types. There's stored cross-site scripting, or type 1. There's reflected cross-site scripting, which is type 2. And then there's DOM-based cross-site scripting, which is type 0. Stored cross-site scripting is what happens when an application receives data from an untrusted source, and it includes that data within its later HTTP responses in an unsafe way. A really good example of this would be someone submitting malicious code to like a chat form, and then when other users end up visiting the blog page or that chat form, they'll end up receiving the application's response, which would include the malicious content, and then execute within whichever user's browser that is. Reflected, the best example that I could give for reflected cross-site scripting attacks would be if you ever look at the phishing attempts that you might get in your email. So you might see that it's pointing to a URL that looks similar to the one here on the PowerPoint, where it has a script in it. These are mainly targeted towards one victim or a group of victims, like a team at an organization that somebody might be trying to compromise or get them to expose credentials for internal stuff. And then we have DOM-based cross-site scripting. So DOM-based cross-site scripting, it simply means that it's a cross-site scripting vulnerability that appears in the DOM, so the document object model, instead of the HTML. What this really means is that the payload is in the response page, but it's not going to be, essentially it's not going to be found in the response. The payload cannot be found in the response. All right, next page, please. So now, for years, most people thought that these stored, reflected, and DOM were the three main types of cross-site scripting. But in reality, they actually do overlap. So you can have both a stored and reflective DOM-based cross-site scripting attack. And you could also have a stored and reflected non-DOM-based cross-site scripting attack as well. So in recent days, they've clarified it, or they've categorized it into two different categories: client cross-site scripting and server cross-site scripting. And it's exactly what you would think it was. The client cross-site scripting is going to occur on client side, and server cross-site scripting is going to occur on server side. And next page. On to you, Ray.
Okay. Cross-site scripting was first discovered in the late 1990s and early 2000s when a Microsoft engineer was messing around with the code and kind of altered it and then tried running it through a program which caused cross-site, which allowed them to go and categorize it, as Jackson was just talking about. Over 50% of all the websites on the internet and been vulnerable to a cross-site. Due to the growing impact of the technology era in growing websites, scripting is continuously growing. Shows that cross-site scripting is almost up with the percentage on information leakage, being the number 3 most vulnerability that websites are faced with.
Cool. So a sort of recent example of cross-site scripting was back in 2014 with eBay. The attack process would go this way. The attacker would publish a new item, such as like an iPhone or a laptop or whatever's popular at the time. During that process of creating the product on eBay's website, they would put the malicious code in when they were creating the new product listing. Then, once the victim was interested in, say, a laptop or iPhone, they would click on that product link, and that link would redirect them to a fake login page. The login page would be styled similarly to the eBay login page. So the user might think that they were logged out for some reason and they enter their credentials, and then they're redirected back to eBay to a legitimate posting for that offer. And then the attacker would then have the victim's credentials. Next page, please. In the next slide, a listing could look like this. And next slide, please. And then once you click on that link, it would be redirected to us. Would be an obvious, obviously not eBay. And next page.
All right, cross is able to be prevented by 2 different types of people. The main one's users. When the user's on a web page and they don't want to work with scripting on the pages or anything, they have the ability to go in and disable scripting on the pages in order to prevent the sites from cross-referencing one another. A major thing a user can do is to completely avoid or limit the amount of social engineering or experience. So like if they receive an email with a link to purchase a product or something, they want to make sure they validate the product before they're clicking. Could prevent or could cause them to go to a different site, cross-citing it. They can update their web servers periodically. And the main thing the user can do is to make sure they're accessing directly and not through a third-party service. Sorry about the dogs, guys. Because when they access, it causes them to be redirected to a different website, causing the cross-site scripting. On the developer's end, they can configure the program to accept specific user input. I know in my programming class, we had to validate input in order to output certain code. On the developer side, they can also scan the application and patch the vulnerability when they find it. The developers are able to also update their side of the website and their servers in order to install the most recent patch or the Open Bug Bounty Program. Jackson has some more information on that one.
Yeah, so another way that developers or an organization could better secure their platform would be through partnering with like BugCrowd or HackerOne, where they would offer certain in-scope domains that would be able to be targeted by the public, basically. And then if it's found and reported, the individual that would find it would then get a reward of some type. Actually, in the past week or so, there's actually a cross-site scripting vulnerability found on Facebook with the login page, and the individual that had found that vulnerability, he ended up getting around $20,000 as a reward for that. Yeah, that's a good way to do it, as long as the attackers only focus on in-scope domains. And next page. Oh, cool. And then we'll transition over to the live example here. I'll be doing this on my screen. All right. Are you guys able to see my screen?
Yeah.
Awesome. So our first example here is going to be a very, very rudimentary one. If you look up here at the domain, you may see this web page and you say, hey, how are we going to actually attack this? First place we're going to look here is in the URL. If we go over to the actual web server where this is being hosted, if we just go in here to example 1 and examine the PHP code, you'll see that we're pulling the header and the footer there at the bottom. And then here in this, it'll say hello, and then the PHP script here in the middle is saying, hey, I want to get the query string that's after name. So our point of attack here is going to be right here where it says hacker. Now with this specific example, we have no type of preventative measures in place. So what we're going to do is we're going to initiate a script here to call the alert function from JavaScript. You'll see it's successful here. That's where an attacker would put in malicious code and then send it to, say, like an individual in an email. That would be reflective. Our next example that I'm going to show you guys is going to be example 4 here. Now this one's a little bit different. Even if we go ahead and type in script, we'll get it thrown an error. So looking over here at the web server again, we'll see here on the third line down, we're checking to see if the word script is anywhere in there. And then if it is, we're going to stop what we're doing. We're going to throw this error that we see here. So this is a basic form of checking for words and then not going through if there are words. To get around this one, instead of throwing the script tag in here, we're going to start out by referencing an image that actually doesn't exist. And we're going to use the onError to then call the alert function in JavaScript. So we'll just use sample image in this case. I can type. Then after this is going to be our onError. Our call to the alert. You'll see here somewhere I made a mistake in my typing. And my issue here is going to be the quotes. Yes, they need to be seen. There we go. And that calls that one. Now for our next example here. The next one's more just of a proof of concept. Looking over here on our website here, we're getting this alert and it says, please don't patch me here, have a kitty. And it loads the rest of the page after you click OK. So how we're going to patch this is we're going to I created a function up here called _patch. Inside that, we're going to be using the HTML special cars function. And then down here where we're calling the script, we're going to go ahead and use that patch function. Save it. Now we'll reload the page. And here is our script that was executing before, or rendering in the browser before. Basically what HTML special cars does is it will take those special characters, convert them over to HTML entities so they're not dangerous. Yeah, that is our live demonstration. Back over to you guys.
Okay, is it showing up all right?
Yep.
Okay. So this is like the consequences and legal issues. First consequence is the easiest and most obvious one. It's personal data loss. The attacker can gather cookies or other session information, which leads to the attacker taking over the account, or they can even gather usernames or passwords, or depending on the purpose of the site, they can gather even more than that. So let's say it's some kind of shopping or banking site, and they steal your username and password. They can go in, gather your address, credit card information. Banking sites, they might be able to gather a social, although that still shouldn't be stored in plain text, but it depends on the security of the site. The attack can alter information on the company site. So this can lead to misinformed consumers, which could cause them to not buy the product or plummet stock prices. So let's say, for example, Tesla posts on their website that they're releasing a new car next month. Normally that will skyrocket their stock prices, and people are just gonna generate a lot of interest. But if, for example, someone rewrites a cross script, and somehow when people start to click on the website, it rewrites that article saying that they're releasing a new one to saying that they're shutting down next month, that can cause stock prices to plummet. And there's really no way to monitor for this. Like, Tesla won't get a website saying, or get a notification saying, hey, your website was compromised. Thousands of people could see it before someone goes to Tesla and is like, hey, you should probably check this out. In extremely malicious scenarios, the attacker can actually alter site information to incorrectly display information about health topics, such as, let's say, medicine dosages or stuff similar to that. This can lead to people following those recommendations that are false, and that can lead to sickness or death. There's really no limit to what people can do as long as the website, if the website's completely unsecured, there's no limit to what they could do on the site, rewriting it, downloads or anything. Different websites have different levels, so it'll affect that, but as a general, there's really no limit to it. Cross-site scripts can be written to falsely represent website images, links, or etc. on an existing site. When it's written like this, it can cause users to click on a link that they would not normally click on, or a link that appears safe and is just covering the original download link. This can be used to download software onto the user's machine. Once the software is installed, it can lead to a lot of issues. It can limit user access to the machine. It can completely make the machine useless. It can cause the machine to even become a weapon for the attacker. So for example, if a website is causing users to download software onto the machine and then turn that machine to attempt a DOS attack on the website, it might not be that big of an issue if 1 or 2 people do it, but if a couple dozen or a couple hundred people end up clicking that same link and downloading that, and runs the program that turns your computer to basically run a DOS attack on the website, they could even corrupt or shut down the website. Lost my place. All of these negative results can cause legal issues. So the first is that when users have their information stolen, they personally might face legal issues. So if their credit card information is stolen, they could end up having a bill for credit card stuff that they didn't pay for. And if they didn't notice soon enough and didn't alert the credit card company soon enough, they could still be responsible for paying back those debts. Basically anything that requires that personal information could be at a loss for. It could cause a legal issue, whether the website is responsible for it or whether the user themselves is responsible. In the example I used before about the website having altered information that could lead to death or something, the website could actually face charges for this, even though they weren't the ones who published whatever is there. Depending on the state and what laws that state has, it's the website's responsibility to be aware of what's being shown on their website, and if their information is false and leads to something like this, they could be in trouble for not having that vulnerability properly secured. It could also have an effect on the person conducting the attack. So depending on the severity of the attack, the attacker can face years of imprisonment, with the minimum sentence usually being 1 to 3 years. Sometimes it's longer if it's a more severe attack that affects more people. This can occur even if the attack is not malicious. People conducting an authorized penetration test can accidentally break the law and face jail time, or different state lines can cause issues. So for example, if a company is located in California and they're authorizing their server, which is held in Montana, and the person conducting the penetration test is operating out of New York, even though he has full authorization, it might be legal in California and Montana to conduct that attack, but in New York, it might not be legal to do that, and he could get in trouble. And any of the state laws could be flip-flopped so that it's legal in New York and Montana, not in California. And if the user is breaking one of those laws, they may actually face consequences even though they were fully authorized to access the system. And I think that's all I have. And then we have a couple of our sources, and that should be it.
Okay, any questions? We've got about 7-8 minutes left for this session. Everybody's always so quiet. This is the kind of stuff you need to play with if you're going to be breaking systems and doing the hacking. All right, we will reconvene at 4:15 and we will do our second session. That'll be with Brandon and Jonas, and I look forward to seeing everybody at that point in time.